Good morning, everybody. My name is Benoit Quenaudon. I work at Saibo's, a company based in Japan. And so I'll be talking to you about the model view intent architecture, or as I see it. There will be a lot of RX Java stuff, some Kotlin, but it doesn't really matter if you know it or not. It's more about the purpose of what it's doing, and so I'll be explaining what it does. So let's imagine we're having a conversation. I speak, you listen to me, you think about what I said, and reply back. And then what you said is what I will be listening to. I think about this and reply back, and we have this kind of a cycle when my output becomes your input, and your replies is your output, and it becomes my input. And so when we talk with a machine, it's like the same. When we click on a mouse, scroll, even speak, anything, it's our output, and that becomes the machine input. And what the computer does, even playing sound, showing stuff on the screen, it becomes our input. And it's like this basic cycle. It's basically what is the human-computer interface. And so the MVI architecture is a proposal to organize the code between the UI and the presenter of your model using this pattern. So it looks like this. The user is us, so getting something from the screen, then pushing something to the computer. Intent is just listening to the user. Model represent the kind of the business logic of the machine, thinking about what we just said. And view is just rendering stuff back to us. And so there is a few things that I think are really different from other architecture. First, the UI is separated between two. Usually when, I don't know, MVP, you would have the view that would be rendering and listening at the same time. But here it's really separated. And we'll see later why it's a good thing. And also there is the user in the architecture. Usually it's not here. And also, not only the name, but every component is written as a function, meaning every component of the cycle is a basic function which output becomes the next function input. What I mean is the user produces a result that will be passed to the intent, then to the model, to the view, and finally back to the user, and we go on like this. We won't be coding any user today, so we can show it like this. So today we'll be coding this screen. It's the to-do blueprint sample app Google is making on GitHub, which has many architecture, MVP, MVVM, and now I'm actually making the MVI. And so it's a basic to-do list. There is tasks. You can complete them, active them, filter them, and so we'll see what we can do. And our architecture at the moment is only this. We didn't write anything, so there is the user at the bottom, listening, and which will click, scroll, anything. And so what we'll do, we'll use a sealed class, and we'll modelize every action the user can actually make on the screen. And so first, when the user opens the app, opens the screen, this is in itself an intent. So we'll call it an initial intent. And because we don't need to pass it any data, we just make it an object, which is a singleton in Kotlin. Then you can see at the top there is a swipe refresh layout. So when the user refresh, this is an intent as well. So we'll create the refresh intent. Then you can check the task or uncheck it. That will make it complete or active. So we'll take one intent for each. And here we need data. We need to know which task has been checked. So we just pass it to a data class. Then at the top there is the menu clear completed. So we just clear all completed tasks. We don't need any data, so we make it an object. Then there is the filter. We only show the completed, the active, or any task. And here we need to pass the filter to the data class. And so here with 6 classes, we have everything the user can actually do on the screen, except navigation. Navigation is just out of the scope. If I have time at the end, I will speak about this a bit. And then, so from directly from the UI, not in the presenter, directly at the source, we'll just emitting intents through an observable. So first, the initial intent is just on creation, we just one event intent using the initial intent. Then we'll merge with all the other intents. For the refresh intent here, we're using Rx binding, just transforming a click listener into an observable or click. We map it to create the refresh intent. And then we'll do the same with all the other intents, just listening to clicks, wrapping it in our intent class. And so that will be the output of the fragment. So we're here. The purple represent a logic, a function, and the yellow is just an immutable object. So one object going through the stream. So now we have our intent. And for instance, when we opened the app, there was an initial intent, and it doesn't really mean anything to the business logic. It could be, depending on your task, it can be anything. And so because we don't want our business logic needing to understand the UI, we'd like to decouple both. And so here we'll kind of translate the intent to an observable of action. And to do this, it's a basic when statement. And because we are using a sealed class for the intent, we can use the when statement, as I said, and you don't need else. And for instance, if you add a functionality, there is a new intent, and if you forget to code anything here, there will be a compilation error, so everything is good. Then, so it takes an intent and returns an action. The initial intent is basically load and filter the task, and we pass it a default filter. Refresh intent, we just load the tasks. Activate is the same, and we pass it the task from the intent to the action. And you can see intent is highlighted in green. It means Kotlin had just did some smart cast. In Java, we would need to cast the intent to an activate task intent and pass it to the action. Kotlin is really nice here. We don't need to care about this. Complete task is the same. We pass it. Clear completed is the same. And change filter is the same as the initial intent, load and filter task. And here we pass the selected filter. And so that's it. Now from 6 class we get 5. And so even if it's really a subtle difference, we can see how the decoupulation was a good thing, because it means we can reuse one action from multiple intent. And now we don't know anything about the UI actually. What part of the UI triggered which action we cannot see here, so it's a good thing. So we have our action, and now we can go inside the business logic to process the data we need. And so in the action observable, there is the load task, load and filter, activate, anything. And because we want to keep the business logic isolated per action, we'd like to split the stream. And for each type of action, we just call the correct isolated business logic, and then merge everything back. To do this, we'll use an observable transformer that will take an action and return a result. To do the splitting, there is the publish method, which you can pass a function to it, and the observable will be the parameter. And inside this publish method, you can do anything you want with the observable, as long as at the end you just return one observable. That's why we use the merge function. And so inside of it, we just check the class of the action, its type, and then just pass it to the correct business logic. So the load task action will be composed to the load task processor, and just the same for every kind of action. So we'll only see one processor. The load task processor will be taking a load task action and return a load task result. So we do a switch map, and we call the repository to get our task, which will return an observable of list of tasks. Then here, and not before, we say inside the stream we send an event saying, hey, I'm doing stuff in the background, I'm loading stuff. So we just have a singleton object that we emit into the stream. When the data correctly return, we map it to wrap it in a success object. So it's basically just the list of the tasks. And when error happen, you don't want to raise anything. The error is just it's just data that you want to pass into the stream. So the UI could just, I don't know, show the error, or you can do anything you want. And because, I don't know, it can be database or the network, but you're doing stuff on the background, so subscribe on IO and observe on the main thread. There is a small optimization we can do here because the in-flight object doesn't need to run in the background. And even if it just comes back right to the main thread, because it's above the observe on main thread, it will be emitted in the next frame. So depending on what you're doing, it can the user can see it at a small jank on the UI. So you can just move it below the observer on, and it won't change any logic. It will be emitted right away in the main thread. So no problem. And so we'll do the same for each processor, which the specific logic, emitting specific event when we are doing a asynchronous task, anything we want. So from intent, we get action, and from the action, we get the result. So as we saw, the load task result, even if it's the in-flight success or error wrapper, is not enough to render a screen because it's really specific to the load task action. So what we want is a class that will be sufficient to render any screen we want. And that's what we will be calling the view state. So the view state, there was the swipe refresh. So we would need a Boolean to just control its state. Then we'll handle the filter, so we can change maybe the label of the screen. We'll have the list of the tasks, so we can display them. We need to hold the error, so we can show some message. And then we'll have 3 booleans that would be kind of a switch, kind of switches, which mean if I complete a task, the task complete will be true, and when true, then I show a snack bar saying the task is complete. And it will be the same when activated or when I cleared everything. When it's false, I just don't do anything. And that's it. With this, I should be able to render any screen I want. And so before the user even emitted the initial intent, we need to have our default state. What's the default state? And so we'll just create one using a companion object. So no loading, the filter is default, no task, and everything. And so in the stream, we get result, and we need from this result to update the state to get a new state that will be rendered on the screen. And so this is usually what is called a reducer. And so we take the default state, we have our result, and we just update the part that is concerned, and we don't touch anything else. So if it was the load task in-flight object, it just means we are loading. So in the view state, we would change loading to true, and that's it. Then we'll create a new state from this and emit it into the stream. But because each time a result arrives into the stream, we need to update the now previous state. We need to cache it somehow. And so to do this in our Java, we can use scan, and you pass it a default value and the reducer. The reducer is a by function taking a view state, so the previous view state, and a result, and just returning a new view state. So as well as intent and action, result is also a sealed class which has every kind of possible result. We just when match it. So because of this, we have the smart cast, as I said earlier. Then we can check the result if it's in flight, success, or failure. If it's in flight, we just take the previous state, only change loading to true, and return it. If it's a failure, we're not loading anymore. We store the error, and we return. On success, we just store the list, and we are not loading anymore. And it's the same for the other result, just updating what we want. If it was like an activate task, we would say, I don't know, maybe not loading, or if it was a synchronous, you just said task activate true, and that's it. And now that we have our state, and it's sufficient to render any screen, we should just render it. And it's basically the last step of the cycle. So we take the state and render it. So the rendering is really, we don't need to think much. We match the isLoading state to the swipe refresh layout. If there is an error, we show it somehow and then return. About the snack bar switches, if any one of them are true, we just show the corresponding snack bar. Then we check the list. If it's empty, we show an empty view and the corresponding label matched to the filter. Then if there is data, we pass it to the adapter, hide the empty view, and change the label based on the filter. And so the render function is like this. It can get a bit long, but that's the only place that should write the view. That's the only place that should change something on the view. So if anything goes wrong, you know where to look. And so the loop is closed. We have our cycle. But we are on Android, and so there are some specific things we need to consider. So side effect. So it's not the correct definition, but what I mean by side effect is if you read or write something that is not the parameter of your function. So when, of course, we need side effect, otherwise a program would just be a black box, no input, no output, it would be meaningless. So in the intent logic, we listen to the user. That's kind of a side effect because we are reading the view. The user checked a task. We are listening to the click. We get the actual check task, pass it to the intent, but we are not writing anything. This is not somewhere where you, I don't know, if the user swipe refresh, you would not do loading equal true, then do your async task. That's not where it should be. So only reading the view and that's it. In the processor, you do business logic, so it's you do whatever you want. But at the same time, the side effects are restrained to the green area. The processor should not talk to the view saying, "Oh, I'm activating this task. What's its current status or anything?" You cannot and should not do this. And in the rendering, even if it's in the UI as the intent, we do not read the view, we only write it. We have the view state, and from it, we should write the view, and that's it. And so on Android, physically, we have the input and the output at the same place, right? Because everything is on the screen. Even the code, everything is either a fragment or an activity. But if it was a computer, the keyboard and the screen are not together. The program is not at the same place, and so there is meaning separating both. And so whatever you render, it should not trigger an intent. Whatever the intent, it should not write the view anyway. And everything else is there is no side effect. Basically, pure functions. So easy to test, and you don't need to worry about thread and everything. And so if the processor wanted to talk to any other component, the only way he could would be to pass a new event into the stream, and go the same for everything. There is only one way the data can run through the stream, and that's basically what's called unidirectional data flow. And that's it. Now, how would we actually code it? So we want less code as possible in the activity or the fragment or anything Android related, because it's hard to test and we want to be able to test anything on the JVM. So only the rendering and the intent listening should be in your fragment or activity, and then you go into a view model. The name is not really important, it's just there is no Android. And so there is the UI and the view model, and basically they can only communicate through those two entries. The UI renders a state, its input, taking from the view model states, which is the view model output. And the other way, the UI emits intent that it's the only entry point through the view model. So let's say the user is using our app, everything goes fine. We render the first screen, and then the user do 3 tasks in a row. Maybe the network is slow. We're not rendering anything yet. And then mom gives a call. So what happens? We stop. So the user was doing 3 tasks. We didn't have time to render. So what will happen to those ongoing tasks in the meanwhile? And is everything lost? That's something we'll see. So let's say at this right moment, the user takes the call. So the UI is on stop. We are not listening. We are not emitting. But the view model is still alive and is still running. So what happens? B is emitted. Nobody is listening. So it kind of a wasted emission. But the reducer using the scan method is caching the latest view state. So we still have it. Then let's say C come back. It get reduced with the latest C state, B state that now is cached as the latest state. It was emitted. Nobody was listening, so it's a waste. Then A comes back is the same. We emitted 3 view states. Nobody listened to it, but we cached the latest up-to-date state. So when the user come back, we just emit the last state, and then the user just get the screen. Everything is up to date, no problem. So how does it? Can we use it for config change? Because it's also something really tricky. So basically, we'll be using the view model ID of the architecture component, meaning even if the activity rotate and that the activity is destroyed or recreated, the view model just stays alive. There is no new instance. There is nothing as long as the activity is just rotated. Once it's totally done, the view model dies, and we don't care anymore. And there is a problem. So everything goes from the intent to the render, meaning the intent is the source and the render is the subscriber. So when the activity is destroyed, the user interface, the source disappears, meaning the stream completes and everything dies. So if we had ongoing task, it's gone. The latest cached view state is gone. And so what we can do is put a proxy inside the view model that will just forward everything from the source, from the intents, to the stream. So even if the source disappears, the proxy will stop the completion and keep the stream alive. But because the UIs actually disappears totally, the subscriber as well goes away. So in the other way, the stream is destroyed, no cached view state, and no ongoing action. We do the same. We put a proxy in the other way. So when one goes out, the proxy stop the completion and everything's fine. So even if the activity is destroyed, the view model, the stream inside the view model is still alive, ongoing tasks are still going, and the latest cached state is still here. And so when the UI comes back, we just need to bind back and everything's fine. How we would code it? Inside the view model, so we create the proxy for the intents. It's a basic subject. And process intent is coming from the UI, so we just subscribe to it, meaning we just forward every intent we get inside the intents subject. We create the proxy for the states, and it's basically what we just return as a view model. Now, when the view model is created, we have the logic we had earlier, and at this very step, we already subscribe to it using our proxy state subject. Which means even if the UI is not listening, you do a new task view model, the stream is created and is alive. And as long as the view model is referenced, as long as it's not garbage collected or destroyed anything, everything going from those 2 proxies are well. And so the fragments, you just so you create your view model. Then on start, you will just subscribe to the state of your model or the view model and render any states you get. because the activity of fragment has a shorter lifecycle than a view model, you don't want to do any memory leaks, so you manage it in a composite disposable, and then you pass all the intents you have to the view model. That's basically the binding of the two entries. And then on stop, you don't forget to dispose of the subscription you have. And on start, the order of first listening, then emitting is important. Otherwise, if you start emitting before listening, there is a chance an emitted view state would be just wasted because you didn't have time to listen to it. And so that's it. There is another problem though. So in our UI intents, there was the initial intent that was interpreted as a load and filter task action. When there is a rotation, the fragment is newly created, meaning there will be a new initial intent going through the stream. But because everything is in the view model, we don't want to load and filter the task again, right? So the solution I came up with, it's not really anyway, I'm not proud of it, but anyway, I use the scan, another scan. And this one is a bit different from the one below because it doesn't have a default value passed to it. There is only the reducer. And this reducer takes two intents and return an intent. And so because there is no default value, it can only be run when there is at least two values, meaning the very first time we open the app, the first initial intent doesn't go inside this scan because it's the only value there is. Meaning, if I'm in this initial intent filter and there is an initial intent, it is a rotation, just a rebinding. So I can translate this new intent to get last state intent that we created in the meanwhile. And if it's not an initial intent, we just pass it as it is. And then that's it. You can do any rotation you want, ongoing task or well. Latest cached state is fine, and no problem. So sorry, there was another conference when people were reviewing an app, and one of the guys said, "Oh, set it on airplane mode and rotate the screen." Everybody was laughing, but using this architecture, we all find because we will just be showing the latest state without even needing to call the database, network, anything. So test is actually also really simple. We get rid of the view model, and we just need to pass a state to the UI because it's the only entry point actually. So we create a subject and pass state to the rendering function, and then using Espresso you can test from this state. I don't know, the swipe refresh should be loading, this view should be displayed, and separately the other way around. If you want to test the right connection between the buttons or actions, the buttons of the UI and the intent function, you just need a test observer, and using Espresso, you click on a button, I should get this intent, and basically that's it. And that's the only test we need to run using Espresso. The other way, there is no UI, we just need to pass intent to the stream and then to listen what state has been emitted, right? So using a subject, we can emit any intent we want. And at the other end, okay, that's the state I should get. I don't know, if you do a load task subject intent, you take your state and you just check that loading is true, for instance. And so that's the end-to-end really big test. You can do also the reducer and the intent interpreter were pure functions, meaning no side effect and idempotent. So you only need nothing at all. You just pass an input, see the output. If it's correct, good, and otherwise there is a problem. But easy to test. And sorry, as before, this one as well run on the JVM. We don't need Android at all. This one as well. And lastly, so the processor was a mix of every isolated logic, right? You just need to, for each, you can do separated tests with a subject and a test observer. And so the blueprint sample I'm actually coding with someone else is here. It's not done yet, and it's in Java, so it's a big mess actually. But if you want to check it out, please do. And so what's not so good about this architecture? So first, I think there is a lot of boilerplate, like creating a class for each intent, each action, each result. You can have a really big reducer, and having to create a task every time, especially in Java, is really a pain in the ass. In Kotlin, it's one-liners, so it's either an object or a data class. And then casting also is really bad in Java, because you would do a switch statement, which type of intent it is, then you need to cast it to an action, and it's a big mess. But as well, Kotlin do the smart casting stuff, and it's a blessing. As well, navigation, it's I ask other developers what they think about this, and it's always a tricky subject. Do you pass the navigation inside the stream to do the navigation to the rendering, or because it doesn't affect the state, do you always navigate from the beginning? It's something I think needs to be figured out. And of course, there is a lot of RX Java, so if you're not using it, it's a bit trickier to implement. But I think it's still possible, because the main idea is just to have an object that you pass to the next component, and from the view state, that should be the only place when you render anything on the screen. And using this, actually, it's really simple, because every part of the stream has its own purpose. So if anything goes wrong, you know where to look. And I don't know, to add a new functionality, it's just basically a new intent, a new action, a new business processor. Then you just update the reducer for the view state, and then it's okay. There is no conflict between, I don't know, some other method did set the loading to true, so my screen is messed up, stuff like this. Everything is really separated and easy to maintain, and I think about. And so that's it. Thank you very much.